Hello. Happy Halloween, everyone, I guess. No one seems to be dressed up here. But that's okay. Earlier, earlier today, there was a class where there was like one person dressed up, and I just felt really bad for them. But that's a whole story on its own.
Dress up, look.
Oh, we do have someone dressed up. Yay! Yay! Awesome. So yeah, welcome back to Backend. We are now in the final stretch of the core series of Backend, and we're going to be covering deployment this week. So yeah, very exciting stuff. Finally wrapping up this semester for Backend at least. So as usual, just two announcements. Attendance grades, like up until this point, have been published on CMS. I did that earlier today. And PA5 is, as usual, due in 2 days on Wednesday. I recommend you don't use slip days on this if you have any left. It's a really easy assignment. It's kind of very similar to demo. So just like get a bit of stress off your shoulders for the end of the semester. So yeah, and then what was I gonna say? I was gonna say one more thing. Can't remember. I'll get back to that if I do remember. Yeah, okay. All right, so let's just review what we covered last week. Right, so last week we did step one of like the two-step process of deployment being containerization, right? So we took all our code, all our fabulous code that we wrote on our computers and packaged it into this neat little container called an image. Sorry, that's kind of misleading because the other thing's called a container. But a unit of software called an image, right? Which we then, push it onto Docker Hub. And now if anyone downloads that image, they can run it as a container on their machines. So that's what we covered last week. Any questions about last week's stuff? If it was confusing at all? No? Cool. Okay. So this week, we'll be talking about servers and actually deploying your apps to our servers, right? So let's briefly talk about what deploying even means. So currently, all of your apps are on your local computers, right? No one else can access it. However, we're going to change that. We're going to make it so that it's publicly accessible through, whether it be a URL or, like an IP address, so that, other people can actually access and use your app, right? So that's where servers come in. And if you recall from lecture one, servers are also just computers, right? They're just massive computers hosted by different companies. Servers are computers that run your Python or your app.py file, right? So that means that it accepts and responds to requests made by a client, right? Being your devices, your computers or your mobile devices. And requests are, again, made over a network. So this means using the internet, right? So the internet is used to send a request from your, say, like your iPhone to the server, which then the server responds with and sends you back resources to then display that onto your screen and whatnot. Cool. So that's the server, right? So there's a few different types of servers. Right? So there's three listed here. The first one is a web server. A web server is just something that shows pages and runs apps on a web browser. So something you'd be actually interacting with on your web browser would be a web server. An email server is something that manages sending and receiving emails. So like email bots or like subscription kind of related emails run on an email server. And an identity server is one that manages logins. So if you log into a like a website, usually that would have its own separate server because it's usually a more like what's we call it? Like it's like more, it needs more security to it, right? Because we have to be protecting the security of the users. But that's just three examples of what servers can do. So again, like I mentioned earlier, right? Servers are just computers, and the network is the internet that we're using to like access these servers and like interact with them, right? So every single internet server is assigned this thing called an IP address. And an IP address is just a string of numbers, right? Or it's like a string of numbers and like dots. So it looks something like this. So for most of the semester, right, you've been using your local environment, and your local environment has the IP address 127.0.0.1. I don't know if y'all knew this, but that is actually the IP address of localhost. Localhost is 127.0.0.1. So if you replace localhost with that, that will also, like, your request will also work. But each IP address is usually connected to a string of letters, right? That's more just easily usable by users. So google.com is obviously much more easier for us to remember than like a string of random numbers, right? Localhost is easier to remember than 127.0.0.1. So servers usually have, an IP address associated to it, but then the IP address is usually also associated to what's called the domain name, being the google.com thing. And domain names are translated into IP addresses. So this conversion happens in what's called a DNS resolver. So we also covered this in lecture 1, but it was a bit complicated back then. So in case you missed it, here's a little depiction on what that would look like. So that's your computer on the top left, right? So the first thing you do is you type in google.com on your URL on your browser, right? And it sends where's google.com to the DNS resolver. The DNS resolver then converts it into a string of numbers, which is then sent back to your computer. And then your computer automatically kind of accesses that number for you, which will then communicate with the Google server. Cool? Does that make sense? Awesome. All right, so now that we know what servers are, right? Now that we know what is used to interact with them, i.e. the network, right? Let's get into deployment, actually putting our apps onto the internet and allowing public access to them. So there are a few things that our app needs, right? Our app needs to be always running. Again, right, going back to last week's example, if let's say you're on YouTube and the CEO of Google goes to sleep and you can't access Google and YouTube anymore, that would be an absolute tragedy. So our app needs to be always running. And so we usually want a separate machine or like a computer to dedicate to running that app, right? Rather than like our local computers. It also has to be open to receiving requests. So in similar vein, right? We always want it to be open, so like accessible to sending in requests. It also has to be publicly accessible on the web, right? So if it's restricted to your local computer, no one else can access it but you. But to change that, we want to make it publicly accessible. And we also want to make sure that the hardware is managed for us, meaning, right, we don't want to like actually take care of this computer physically. We want, say, like a Google or like AWS or something along that line to like kind of handle the hardware stuff for us as well. So we're going to be renting a server. And the reason why we want to be doing that, again, is because we want to be running the server on the internet, i.e. the cloud, than just on our local computers, right? So this rented server will actually download the image that we made from last week and then make it into a container and have a live instance of that container running on the server. Again, an image is the most minimal version of your app possible. So your server isn't actually going to require that much space to run your app, or it's going to require the minimal amount of space to run your app because your container itself is already so small. And the server is going to be managed by a cloud service. So we'll show a few examples of cloud services in a second. But that means that we don't have to physically maintain the computer, right? That'll be handled for us. And we also are provided tools on how to automate stuff like security, scaling, which I'll cover later, and like crashing of your computer. So a few of the cloud services that are popularly used right now that a lot of you might actually know are these four, right? AWS, Amazon Web Services. DigitalOcean is the one that AppDev uses. Microsoft Azure is a pretty big one too. I use it once in an internship. And Google Cloud is the one we're going to be using for this course. So if y'all didn't see, I made an announcement on Ed earlier today. And you guys all should have free Google Cloud credit, which is awesome. This means that your app is going to be locally run, or actually running on a Google computer without you having to pay. It also saves you the free trial that you have that each account comes with. So if you ever want to like keep your app running after this course, you can depend on the free credit for as long as that lasts. Okay, so right, so we just covered that we have this server, right? Another computer that actually runs our apps. So how do we actually, us as administrators of these computers interact with this server, right? The computer. That's done through this thing called SSHing, or Secure Shell Network Protocol. This allows the user or administrators to access a computer in a really secure way. These 3 bullet points really boil down to just being able to access the terminal of your server, sorry. So just like we have a terminal open on our computer, right? We're basically going to be SSHing, and that allows us to access the terminal of the server computer. So open and view resources, execute terminal commands, and installing packages and all that stuff is going to be done through the terminal. Partially why it's important that you guys get familiar with the terminal is because a lot of the time you're not going to be able to open an entire desktop view of like a separate computer. You're just going to be using a terminal. But that's kind of out of scope of this class. So does this make sense? Awesome. So this is one example of how you would actually SSH into a server. This is how you would SSH into Eatery's server. So if you look at the very top, the command that we ran is ssh/-i server.pem appdev@eaterybackend.cornell-appdev.com. The syntax here isn't too important. One thing to note is the server.pem, which we'll be covering in a second, appdev, which is the name of the user that's actually trying to access into the server, and eaterybackend.cornell-appdev.com, which is the host name. This is just going to be like traditionally the name of your app. So again, SSH requires a huge amount of security, right? Because we don't want anyone else to be actually able to like go into these servers and manipulate our code or our data. So, right, one way of having a layer of security is obviously a username and password credentials. This is traditional in a lot of web apps, right? Web servers. But you may have noticed that a lot of, a few sites have actually moved on to these things called keys, right? Like for example, GitHub. I don't know how many of you have used GitHub yet, but GitHub actually doesn't allow you to use your username and password in the terminal anymore. You have to use like a developer SSH key to push and pull code from GitHub. And the reason for this is because these things are called public and private key authentication, and it's a huge string, right, that is encrypted so hard that it's usually more secure than like really long passwords. If you really want to look into it, you can look into what's called RSA encryption, but that's outside the scope of the course. Just know that we're going to be using keys instead of username and passwords because they're more secure. So how does this tie back to what this command is? Server.pem is usually the file that contains this key. This contains this huge string, and usually you don't really distribute it. You as an administrator is like the only person who has their hands on this PEM file, and you would use it to log into your server. Okay, so layer of security important, right? And then the next thing is kind of like the flow of like SSHing into an actual server. So the first line, the first bullet point is the traditional, just like standard syntax of SSHing into a server. You type SSH, you specify the user and the domain of the server. Again, this comes with a lot of configurations, like being able to pass in the PEM file and whatnot. But the baseline that we're going to be focusing on is this first line right here. Then when you try to SSH into a server, you're going to be prompted with the server's key being, like the password, right? Not really a password, but like the key, right? To like authenticate into the server. And if you haven't connected to the server before, it actually adds that server to this thing called known host, which is kind of just like an environment variable on your computer, which will allow you to access the servers much more quickly later on. But that's just kind of what happens under the hood, not too important. And if you successfully authenticate using public private keys or credentials, you'll open the command prompt, so the terminal of your server. And that's how you actually interact with like your files and download the image and run the containers and so on. Okay. We can chill for a bit. Does anyone have any questions so far? Does that make sense? Yeah.
So, like, can you show like what does SSH sort of service do?
Yeah, that's a great question. So, again, the question was, why would you want to SSH into Eatery's backend, right? So if you look at the first line of command that's run, right? You see on the top left, it says like tilde/.s/eatery, and then it says, like the three little colored arrows, right? This indicates that, well, I mean, whoever terminal this is, that's what they configured it to look like. Now, if you look at what the terminal prompt is right here, it says appdev@eatery, right? Instead, this means that instead of being on your local computer, you actually successfully logged into the server's computer, and now you can actually start messing with like the files on Eatery's backend, start actually running the app, take it down if you need to, check the logs, and so on. So none of like the files that are running the public version of Eatery lives on your computer, right? Because if your computer closes, we don't want it to shut down. That lives on the server. So to log into the server is where SSHing comes in. That make sense? Okay. Right, so just like last week, right? Last week we covered Docker and containerization, and we're going to be integrating this with Google Cloud. So what does this mean? Google Cloud, again, is a cloud service, meaning a service that allows you to use computers that they own to deploy your server or to run your apps. So once you actually log into a Google Cloud machine, you can download the Docker image that you published from last week, right, from Docker push onto Docker Hub. And then you can run those Docker images as Docker containers on these Google Cloud machines. And what this means is that, since Google Cloud, right, is like a public computer, this means that your friends can now start actually interacting with the app that you've put onto your Google Cloud machine. So this is kind of going outside the scope of this course. Right, for the sake of this course, all we're just going to be covering is like how to actually deploy your containerized app and run it publicly. But these are just like a few nice things to know about deployment that's going to be maybe helpful for you when you start working on bigger scaled projects. So how do we actually optimize deployment structures, right? One method is this thing called clustering. So clustering is having a group of servers, right, that behave as one system. So this means having multiple servers to run one app. And so, like a depiction of that would be like, say this, right? So we have our web application, our file storage, and our database running on one single server, right? The reason why this might not be great is because if, let's say, one of these components fail, we don't know which of those components might have failed, right? And if, let's say, the web application, right, fails, we don't want the entire server to like go down. Usually when, let's say we have Facebook, for example, right? Facebook has multiple different apps that they use, right? They have Marketplace, they have Messenger, they have Instagram, and so on, and like the Facebook actual app. There's times when Facebook Messenger is down, but Facebook itself isn't down, and like Instagram isn't down. And that's because we have multiple servers like such running all these different components all together. So again, this means that if like one of our servers goes down, not all of our servers goes down, so we can still access parts of the app, and users obviously would have a better time being able to access some of your app than just none of them, right? So that's clustering. Clustering is being able to segment out different components of your app into different servers to better identify what failed and also as like a better backup system. And that's actually what's in here, right? So backups and crash handling. Data resiliency is also another big one. If one of your servers is like the only thing that's running and the only one that actually contains your data and that gets compromised, well, then all of our data is gone, right? And that's not great. So having multiple servers to like handle different things is always generally a good idea. The next thing we'll cover is load balancing. Scaling is just having more servers to like run our app in case our app gets like really popular. If you don't scale it, then we can't take in like so many requests into one server, so we just have like multiple servers to handle that. And load balancing is the next thing we cover. So what is a load balancer? Load balancer is this intermediate server that kind of leads requests to like different servers. So we have three of like the same server down here, right? And generally we don't want to overwork one server specifically. So if we have like, say like 10,000 requests, we don't want to send all 10,000 to web app 1. We want to distribute that evenly to our 3 different web apps. And that's what the load balancer does. That makes sense? Load balancer just like evens out the workload for each server to handle. So again, the network traffic coming in, the load balancer kind of, sends it into the web app that's like least used right now, least worked. Right? Does that make sense? Yeah, so that's just 2 ways to optimize running a server, right? Having multiple servers and having a load balancer to kind of like even out the tasks to not overwork one server at a time. Yeah, so I think that is it for, so yeah, if we have a lot, right, then like we want to have more servers and load balance it to even more servers. So that's it for today's lecture, or this week's lecture. The crux of this week is going to be the demo, which is going to be actually making our app publicly accessible. So hopefully you all are hyped, but before that, I am open to taking questions if anyone has any. Good? Okay.
Oh, one question.
Where? Oh, yeah.
Hypothetically, Google Cloud, it's like a server. So are you able to use it as like a
As any other server? What do you mean by that?
Yeah,
Sorry, Minecraft server?
something like that.
Wait, repeat the question.
Yeah. So the question was, can you use Google Cloud servers as like any other types of servers, like a Minecraft server, for example? I'm not sure. Maybe like I don't know how. Okay, so like the point of like a server, right, is to like make things so that it's like not on your computer and you can actually publicly access it. Like anyone else can access it, right? So like if you could hypothetically run Minecraft from your terminal and like open a world on your Minecraft like a terminal, then like maybe. So yeah, I hope, does that make sense? Any other questions? Don't worry, there are no stupid questions. That was funny.
That was a good
Okay.
question. Very interesting.
Okay, let's get into demo.